Chapter 5.1, Introduction to Normal Distribution and the Standard Normal Distribution. Very well, so what we learned so far, we learned that we have two types of variables. A variable denoted by x can be discrete or it can be continuous. So we talked about discrete variable in chapter 4. Today we're going to talk about continuous variable and understand the behavior of the graph of a continuous variable. Let's start by official definition. A normal distribution is a continuous probability distribution for a random variable like x. The graph of a normal distribution is called the normal curve. A normal distribution has these properties. First of all, the mean, median, and mode, they are all equal to each other. So when it comes to a normal distribution and a continuous variable that follows a normal distribution, if they say what is the center, you can describe the center mean, median, or mode. Remember that a normal distribution has bell curve. So in the middle of the horizontal line, which all of your x values are located, you have the center, which is the mean, median, or mode. They are all equal to each other. 2, the normal curve is bell-shaped. It is symmetric with respect to the mean. So this is the center. If I fold this graph, I have symmetry with respect to the vertical line, which lands on the center, mean, mode, or median. What is important? The important part is the total area under the normal curve is always 1. Where is that area? The area is below the curve. This area is equal to 1. Remember that the probability is always between 0 and 1. On the left-hand side, the probability is 0. The area or the probability is 0. As you increase, you get 20% of the area, probability 20%. 25% of the area, probability is 25%. 35% of the area, probability is 35. 45% of the area, probability is 45%. 50% of the area, probability is 50%. 55% of the area, probability is 55. 60% of the area, probability is 65. 70% of the area, probability is 75%. 85% of the area, probability is 85%. 95% of the area, probability is 95. And 100% of the area, 100% of the area, which is equal to 1. Probability is 100% or 1. We shaded all of the graph. Note that we started from left-hand side to start shading the graph. 4. The normal curve approaches but never touches the x-axis. There's always a little bit of gap between these two lines and curves. 5. Between mean minus 1 standard deviation and mean plus 1 standard deviation. In the center of the curve, the graph curves downward. The graph curves upward to the left of mean minus 1 standard deviation and to the right of mean plus 1 standard deviation. These points at which the curve changes from curving upward to curving downward are called inflection points. Very well, where are those points? So, our graph curved downward, then it starts curving upward. This point on the right-hand side. Our graph curved downward, then it starts curving upward. Second point. These 2 points are called inflection points.
Would you please repeat this part again? I didn't understand it. Do you mind if you please repeat it again?
The graph curved downward. Then the graph curved upward. This point dividing the behavior of the graph are called inflection points. These 2 points. Curve downward, curve upward. Downward, upward. Inflection point dividing these 2 being downward and upward.
I see. Thank you.
Sure. What's next? Definition of probability density function or PDF. So far you have learned that for discrete probability distribution, it can be graphed using a histogram. For continuous probability distribution, you can use a probability density function. A probability density function has 2 requirements. What are those requirements? First of all, the total area under the curve is always 1. And the second requirement, the function can never be negative. How do we define a probability density function for a normal distribution? This crazy looking function is probability density function for a normal distribution. As you can see, here you have an exponential function. You don't have to worry about this crazy function. This function is built in your calculator. We also use z-table to find probability for this function. Okay, let us investigate different types of graphs that you see that are similar to a normal distribution. A normal distribution can have any mean and any positive standard deviation. These 2 parameters, mu and sigma. Guys, remember that when you're using Greek letters, it means that you are working with population parameters. Population, not a sample. Mu is the mean of the population and sigma is standard deviation of the population. Determine the shape of the normal curve. The mean gives the location of the line of symmetry. And the standard deviation describes how much the data are spread out. So take a look at these examples. Here, the mean, which is in the middle, is roughly 3.5, with standard deviation 1.5. So this is the spread of the data in the first graph. The second one, mean is roughly 3.5 with smaller standard deviation. Look at the shape of the graph. The data is less spread out. And here, mean is 1.5. Even though these two graphs are the same, the mean on the horizontal axis is 1.5 with the same standard deviation, 0.7. Notice that the curve A and curve B above have the same mean, and curve B and curve C have the same standard deviation. The total area under each of these curves is equal to 1. Also, one of the inflection points occurs one standard deviation to the left of the mean, and the other occurs one standard deviation to the right of the mean. 2 inflection points. Let us move on to example 1. Understanding mean and standard deviation for your data. The first one says, which normal curve has a greater mean? Part 2 says, which normal curve has a greater standard deviation? Okay, let's take a look at these two graphs. For graph A, the mean of the graph is 15. For graph B, as you can see, the mean is 12. Which one is more spread out? Graph B has more spread in the data, so standard deviation of the second graph, standard deviation of B is greater than standard deviation of A, but mean of graph B is smaller than mean of graph A. Example 2, interpreting graphs of normal distribution. So what do we have here? We have scaled test scores for the New York State grade 8 mathematics test, which are normally distributed. So since this question says it's normally distributed, for sure you know that the graph is a bell curve graph. The mean is in the middle, and you have your standard deviations. The normal curve shown below represents this distribution. What is the mean test score? And estimate the standard deviation of this normal distribution. Perfect. Let us look at our graph. We know that we have a normal distribution, so it means that a number on the horizontal axis which divides these graph in halves is going to be our mean. Okay, because of symmetry, our best estimation is going to be a number here. We can say that, okay, it's roughly closer to 700. So it can be 680, 670, 675. any number, any estimation works for you. This is the center, the mean of the data. What you could do, you could take these two values, 800 and 550, then divide them by 2 to get the mean of the data, because this is just the midpoint. 800 plus 550 divided by 2. Now, what about your standard deviation? Okay, how do we understand the behavior of standard deviation and how do we do the algebra? Perfect. We know that our mean is 675. If we want to do the algebra and get the value, how do we calculate the standard deviation? Remember that for a normal distribution, here the mean is in the middle. One standard deviation above the mean, mean plus one standard deviation, mean plus two standard deviation, and mean plus 3 standard deviation are numbers on the right-hand side. 1 mean minus 1 standard deviation below the mean minus 2 standard deviations, mean minus 3 standard deviations on the far left of the graph. So if you have these values, you can actually just subtract them, divide by 6 to find your standard deviation. Or you can use your inflection points. Okay, if I add these two values, I get rid of my standard deviations. I don't have any standard deviation left. If you subtract them, you get mean plus 3 standard deviation minus mean minus 3 standard deviation divided by 6, it gives you your standard deviation. So 800 minus 550 divided by 6. Just an approximation. 800 minus 550 divided by 6. 250 divided by 6. But note that we know that our normal distribution, these 2 points, these 2 boundary points are the points that the graph doesn't touch the horizontal axis. You can say that, okay, instead of working with 800, I can work with 770 and 580. So 770 minus 580. Which gives you 90 divided by 6. You simplify this fraction. 300 divided by, 30 divided by 2. So by subtracting these numbers and dividing them by 6, you can get good approximation about your standard deviation. Because these are 3 standard deviations away from the mean. So this is mean, 1, 2, 3 standard deviations above the mean and 3 standard deviations below the mean. That's why we have to divide by 6.
Let's try a quick question.
Very well. Okay, our favorite formula, z-value. What is our goal? Our goal is to use the formula that I mentioned before, the ugly looking formula, probability density function, which is an exponential function. Our goal is to use this function to find the probabilities. To do that, first, you have to convert all of your x values into z values. This is the very first step. So officially, let us define standard normal distribution, which is a normal distribution with mean equal to 0 and standard deviation equals to 1. As usual, the total area under the normal curve is always 1. The graph is exactly the same as our normal distribution graph, but note that on the horizontal axis, instead of x, we have z. Z can be -3, z can be -2.9, z can be -2.8, z can be -2.1, z can be -2, z can be -1.9, z can be -1.5, z can be -1.2, z can be -1, z can be -0.5, z can be -1/3, z can be 0, or z can be any positive number, z. So our original normal distribution has x values on horizontal axis. And this is just the function, the values, f of x or p of x. This is p of x. Now we use z formula, value or x value minus mean divided by standard deviation to convert x into z, and they are having the exact same graph. It was f of x, probability of x. Now you have f of z or probability of z. Just coming from algebra. Let us talk about area. The cumulative area is close to 0 for z-scores close to -3.50. So remember that. We read graphs from left to right. Z is 0 in the middle, z is 1, z is 2, z is 3. It's always fixed for z graph. Z is -1, z is -2, z is -3. We cannot change this graph. When z is close to -3.50, it means that we are here at the tail of the graph. Our z is here. Z is -3.50. So the graph, the area is on the left-hand side. It's very small, almost 0. So P of z is almost 0. So let me write approximately, approximation, estimation, approximately 0. Again, P of Z is the area, is the probability function. The cumulative area increases as Z scores increase. What's the meaning of that? Now consider using Z equals to -2. Suppose my Z is -2. The probability density function is the area below the graph. So it's not 0. As you can see, I have more shaded portion of the graph here. So probability function, the probability of Z is positive now. Later, we're going to use our Z table to actually find this probability. What is this probability? But for sure, we know that if Z is equal to 0, its probability is 50%. Why? If my Z is 0, it means that I'm just dividing the graph in halves, and the probability function, probability distribution function, includes area on the left-hand side of 0, which we know that it's just 50% of the shape. P of 0 is just 50% of the graph. 50% point 50. This is your probability. Probability that Z is equal to 0 is 50%. That's it. As I increase the probability, as I increase my Z value, I increased the probability. Now, if Z is equal to 1, the area is more than 50%. If Z is equal to 2, the area is more than before. If the Z value is closer to 3, the area is almost 99%. And if I use Z to be 3.5, if Z is positive 3.5, I almost have 100% of the area, which is 1. Very well. Example. Find the cumulative area that corresponds to Z equals to 1.15. 1.15. Okay, here I have my normal curve. I know that these numbers are fixed. 0, 1, 2, 3, and this is Z. -1, -2, -3. Where is my Z? Z is 1.15. Where is 1? 1 is here. 1.15 is a number here. This is your Z. But what is the area? What is the probability? I'm looking for this probability on the left-hand side. P of Z or P of 1.15. What is this guy? Let me show you how to find the probability using Z table. So first of all, you can Google Z table. So let me open a browser and share it with you. In any browser, just write Z table. You can write Z table PDF, so you can download that and keep it for yourself. The first one is good. So let me download this PDF file. And let me share the screen with you to show you how to find the probability for 1.15. Okay? Okay, perfect. Okay, guys. First of all, you have two tables. The first table is for negative values. Your Z values are negative. Take a look at your example. This example says you have positive 1.15. Okay, so let us take a look at the second table. Oh, very well. My second table shows positive Z values. These are all positive numbers. Okay, so I'm looking for the probability to the left of 1.15. How do I find that? So, guys, please listen carefully. 1.1. These two digits, 1.1, is going to be on the first column. You have to look for 1.1 on the first column. Hey, I found 1.1. 1.1 is here. It means that I'm working with the first row here. What about 5? 5 is the second digit after your decimal place. It's a number on the first row, on the top row. Okay? Now, this is the column that shows the area. The intersection between this row and this column is 0.87. So P of Z is 87%. One more time. First of all, my Z is a positive number. I have to use positive Z values, positive numbers. I have 1.1 and 5. The first two digits to the left and right of your decimal place is a number on the first column. You have to look for it. There is that. 1.1 is here. The second digit on the right-hand side of your decimal place is a number on the top row. 0.05. The intersection between these two is your area or probability. So the probability of Z equals to 1.15 is 87%, or the area to the left is 0.87. Okay, perfect. So here you can see a picture of the table. 1.1 and 5, the intersection is 87%. Now the second Z value is negative 0.24. My Z is now negative 0.24. Let's get back to our table. Negative 0.24. Okay. First of all, my z is negative. Should I use this table or the other table? Z is negative 0.24. Look at these z values. All of them are positive. So I'm not going to use this table. I have to get back to the previous table with all negative z values. Okay. So the first two digits to the left and right of the decimal place. Negative 0.24. These two digits to the left and right of the decimal place. You have to look for these two digits on the first column. Okay, where is that? 0, 0 point, 0.2. Okay, I found it. It's just here. The second digit to the right of decimal place is on the top row. On the top row, which is 4. This guy is here. Now, the intersection between these two is going to be my probability or area, which is almost 41%. The probability that z is equal to negative 0.24 is equal to 41%. So you can write P of z equals to negative 0.24 is equal to 0.41 or 41%. That's the area or probability. You have 3 different cases. The first case is when the question says the area to the left. So the keyword is left. You just use your table. You look at your table and find the area to the left-hand side of 1.23. Just use your table. So to the left, directly use table. You don't have to do any algebra. No algebra is involved here. If the question says to the right, the keyword is to the right, then you have to do a little bit of algebra. The outcome is 1 minus the table. So to the left, you only need to use the table. That's enough. No algebra. To the right, you have to do a little bit of algebra. 1 minus the number that you found from the table. And finally, if the question says in between, you have to do algebra and use table 2 times. 2 times. So if it says in between 2 z values, you have to find the first area, table, minus the area for the second z value, table for larger z minus the table for smaller z. Larger z minus the table for smaller z. Guys, you do not change any z value here. Z values are all fixed. You only do algebra on the probability or the area. For example, if the question says find the area to the right-hand side of z, your z is equal to 1.23. You use the table to find the probability or area to the left. Then you have to do a little bit of algebra. 1 minus this area, which is almost 11%. If you have two z values, negative 0.75 and 1.23, you use the table to find the area to the left side of 1.23. You find the area to the left side of negative 0.75. Then you subtract the areas. We don't change z values. We don't do any algebra on z values. Be careful. Okay, let us have 5 minutes, 8 minutes break. We get back and start the group activity.